Now, time is relative, okay? So you can't really put time in a normal distribution, but what you can do is actually just centered about a value and then just try and change it, because now you have the problem now with time is you have the hour here, and you have a minute here. Both are different units, right? 60 minutes is 1 hour, so that's the reason why. Now a student reaches the bus stop outside the house at 7:20 every morning to take the bus to school, and has to reach his school by 7:40, assuming that the waiting time for his bus is normally distributed with this 8 and 5, and the journey is this and this. Okay, good job. Now, this is it. We all experienced this before. 7:20. Every day, we are faced with this dilemma whether to reach school on time or not, right? So then, what do we blame? We of course blame the bus lah. The bus is the problem, not our problem. It's a bus which bring us, whether it's like late or not, is the bus problem, right? Yeah, correct. So assume that waiting time for the bus is normally distributed. So I'm going to W. So he waits here, W, normally distributed, which is actually normally distributed what? 8 minutes and 5, right? So 8 and 5 here, 5 square. Is that variance? Oh, this is variance, my goodness. So this is already variance. So just is 5 already. Okay. And then the journey. So meaning this journey here. Take note of this journey here. To the school. Okay. Journey to the school would then be J, normally distributed, and 11 and 4, variance of 4. Okay. So that's about it. Find a probability that he will take more than 20 minutes to reach the school. That is late for school lah. Huh? Actually, just add both of it out now. I think the first one should be quite fast. So let J and W be the waiting time and journey time of respectively for the student. Okay. Okay, that's it. So in minutes, and then basically we can write this down. Then basically to see whether it's late or not, right? You just need to make sure, because this is fixed ma. Okay. It will need to go through, this guy need to wait first. So from 7:20 onwards, you need to wait first, then go to the journey, then only reach your school. Okay. So basically the probability that it will take more than 10 minutes to reach school, right? The required probability will just be W plus J. You add these both up, because essentially school starts at 7:40, you arrive at 20, meaning you only have an allowance of 20 minutes. Anything more than 20 minutes, you are doomed. Okay? So school starts at 7:40, you reach at 7:30. You just need to make sure that your waiting time plus your journey time if it's more than 20, you are doomed lah. So this is a probability of being late. Okay? Great. So then you just add them up. So W plus J, normally distributed, add them up. So this will be 19 and 9. So just put in key calculator. Should really get answer. That will be 20, 19 and 9. 0.36944. Okay. Second one is, in 30 days, what is the expected amount that he'll be late for school? Because if this is 1 day, every 1 day he will be 36.9% late. Goodness, this is such a bad boy. So this is screwed, man. This student is bad. Okay, so in 30 days, the expected number late, right, will just be n times p, which is just 30 times 0.36944. That's about it. So just take 30. Every 1 day you have that probability of being late, ma. So you just multiply it and then you get 11.08. So it's just 11 days. If you need it to be integer, but you can just write 11.1 days is fine also. 11 days. Subsequently, part 3. Now find the latest time she would have to reach the bus stop outside his house, so the probability of him being late for school is less than 5%. My goodness. Okay, this is where the things becomes interesting. Okay, so this is where you need to hear me out. You know this is 20 minutes, right? This is 20 minutes. The journey here is 20 minutes. Now, this is the problem. Because you reach the bus stop 7:20. The question now is, what time should you arrive at the bus stop so that you have this chance here of being late can go down to 5%, less than 5. So let's try and understand part 3. Now you know that your traveling time is essentially W plus J. I'm just going to use W plus J here, which means this is 90 minutes. Okay, so this is W plus J, normally distributed of 19 and 9. Okay, so where should you cut your 5%? The question now is, should you cut your 5% here, or should your 5% be cut here? And find this, where should you cut? Left or right? One is, if it's very counterintuitive, right, what you should do is you just solve for inverse norm for both sides. It's not hard because it's 5%, right? You want the 5% on both ends. So now you just think about it, right? You just basically need to just inverse norm. Inverse norm. 5% on the left and on the right. So this is 19. 19 and root 9, which is 3. Then left, there will be 14.06. Then you get right side. So in exam, if you're not sure, now this is a very important question because you're not sure whether to take left or right. But once you write it down left or right, right, you know that 23.934. 23. Okay, I'll give you. Okay. So now, how do you read this? This is how you do it. 5% of the journey will only take 14.06 minutes. 95% of the journey will take 23.39 minutes. Now I give you another time for redemption. Left or right? Okay. Let is A. Okay, can. Let A. Okay, I think let me rewrite this down. Sorry. This is what you write. Let A be the traveling time. Actually, you don't need to write it out. You can just draw it out. That is fine. 4 marks will be given. But if you insist on writing, this is what you write. Let A be the traveling time. So hence you want P, because you want PW plus J more than A, should be less than 0.05. Okay. Then what you get is actually this case here. This is your A. Then A should be. You can do a standardization. So inverse norm. Yeah, inverse norm. Not necessary, this one. I don't think it's necessary. It's very hard to write this out. This I don't think is necessary. So what you need to write is this one here. This one. Just inverse norm it the right side. Show that you know that it's right side. Can okay, so now if I talk about now this is 20 minutes. I just have a 20 minutes of traveling time. That's the problem here. 20 minutes. So meaning I need to change this timing here. Okay, I need to change this timing here, which is 7:20 a.m. But I know that W plus J is the time that he travels, right? So this is the time where he travels. Now it says that it must be less than 5% of the time. Okay, like you need to be less being late for school less than 5% of the time, meaning you need to find 95% of the traveling time, right? This is 95% of traveling time. Okay, what I'm saying is a lot of students may think that the 5% is this side here. It's wrong. Because if you capture the 5% here, this is only 5% of the traveling time. 5% of traveling time, meaning on average you are going to travel 90 minutes to school. On average, you're going to travel 90 minutes to school. Intuitively, you should know that 14 minutes shouldn't make any sense anymore. Okay? It should get 23.93 minutes instead. So 95% of the traveling time is 23.93 minutes and below. So essentially, this time here should be, instead of 20 minutes, you should cancel this out and put the traveling time as 23.93 minutes. This is a traveling time. Time is relative. So just now what we did was we put 20 minutes, which is late. Late in the middle, right? But we do not want that. So if we cut, we have a leeway of 23.93 minutes, meaning this 7:20 will just minus off this one and we get 17.16 a.m. Is that okay? So this is 95% of a traveling time. So I take this portion here. My A is here. Basically, this is my A here. This is my A. And your A must be, anything more than this will be better. So if this is your traveling time, what would you will expect is essentially, what do you call it? Leave the house as early as it's like, give yourself the amount of leeway here is better. So if you use 25 minutes instead of 23.95, it will be even better, right? 23.93, yeah. So that's why it's like that. Part 4, what we have is find a probability that the average time taken to travel from the bus stop outside his house, including waiting time for the bus, to school in 30 days is between 15 and to 20 minutes. Okay, good. So, this one is okay lah. Average time taken, which means mean time, meaning if you let x equals w plus j, meaning this is every x bar. 30 days is between 15 to 20 minutes. So this one here, last part is okay lah. Average, right? Average and mean time. So probably the average time n is 30. So bar x, because it's normally distributed, so everyone is happy. Just 19. 9 over 30. Just divide the variance. Enough already. Required probability will be 15 to 20. So okay, there you go. This will just be this will be CDF 15 to 20. 19. 9 over 30. 966. Okay, that's all. Part 4 is just average.